Hi, greetings everyone. Thank you for joining us at Exchanging Ideas 50 Global 5G Evolution. I'm Kanishwaran Gwindasamy, the founder of Global 5G Evolution. A warm welcome to the speakers all around the world. Thank you for joining us. And to the audience, please take a couple of seconds to click the subscribe button on top of our YouTube channel. And today's topic that I would like to present is the KT Corp records the highest contribution of beyond connectivity. This is a information from the latest Omdia report. And this image shows a bar graph depicting the gross revenue growth or decline of various telcos in their B2B segment from 2018 to 2022. And the companies with the most significant declines, including Lumen, Frontier, BT, AT&T, and Telstra. It is possible that telcos with declining B2B revenues have a heavier reliance on traditional connectivity services, which facing commoditization and intense price competition. And this can lead to revenue stagnation as well. So companies that seeing growth might be those have successfully diversified their offerings beyond the basic connectivity. And this includes entering into areas such as cloud services, managed IT services, cybersecurity, IoT, and other digital transformation services. Now, if we look from KT Corp, a leading telco in South Korea, is evolving beyond the traditional connectivity to diversify its business and drive revenue growth. And KT Corp records the highest contribution from its non-connectivity business among its peers. And KT Corp is identified as one of the most diversified telecom companies in APAC, and sectors they are covering e-commerce, cloud services, financial payment services, AI, content and media as well. KT Corp leads in terms of revenue contribution from content and media services, and the growth in IPTV services has been significant, driven by high ARPU. KT Corp's subsidiaries such as KT Studio Jenny and Sky TV have produced original content, including 7 dramas and 5 entertainment programs, which bolstered their market presence in the first half of the year. Now, KT Corp media value chain. These are the quite significant area where in the first section, KT Studio Jenny, a subsidiary of KT Corp, focused on creating and distributing media content. A content studio that produces K content, which is known as Korea content. And number 2 is StoryViz, isn't just about creating content. They aim to build a complete content ecosystem. This includes IP development, production, distribution, direct to consumer. And number 3 is KT Genie Music, which goes beyond just streaming by venturing into other music related areas as well. Now they curate music content, potentially include interviews behind the scene glimpses, and also they have partnerships, collaboration with companies like AI assistants such as Giga Genie, Clova, and Pixbyte to integrate the music streaming functionalities. Number 4 is the TVING. It's a leading South Korean subscription video on demand service. TVING is the result of a merger most recently July 22 between Season, previously owned by KT Corp, and TVING, previously known as CJENM, and now a powerful competitor in the Korean streaming market. Number 5 is KT Alpha, responsible for distributing content rights, acting as a middleman, connecting the content creators with the platform and audiences. And lastly is KT's Jenny TV, offers a comprehensive multimedia experience integrating the IPTV, AI-based services, and smart home functionalities as well. So now we look from this point, KT Corp T-commerce. KT's Jenny TV and KT Alpha have established partnership with leading e-commerce platforms, the G Market and Kopang, to enhance their T-commerce, known as television commerce capabilities. And this collaboration aims to leverage the massive reach and user base of these e-commerce giants to drive sales through interactive television shopping experiences. And this integration allows viewers to purchase products featured in TV shows and ads instantly without needing to switch devices. Now, This is the KT's AI full stack known as the More AI platform, another version of like a OpenAI ChatGPT, a comprehensive infrastructure designed to support the large scale AI model training and deployment as well. And this platform is built to handle the demands of modern AI applications, providing a complete suite of tools and resources from a basic framework level to hardware optimizations. If we look the rate picture here, KT's Rebellion aims to compete with industry giants like NVIDIA by developing high-performance AI chips tailored for various applications, including the data centers and large language models as well. Another fascinating area was KT's K-Bank. Uh, they have ventured into banking using the credit rating delivery platform to enhance its credit risk assessment capabilities. And this known as the CRDP leverage the KT's telco data to provide a more comprehensive credit valuation, particularly beneficial for individuals with limited not credit history. And K-Bank is the first internet-only bank in South Korea, utilizing this platform to offer more accessible and competitive price loan services. And by integrating this telecom data, K-Bank can better access the creditworthiness of applicants who may not have a sufficient financial history as well. Now, for in terms of conventional credit scoring methods, as you see in the diagram, the CCS that leverages data from various sources to assess the borrower's credit worthiness. And by analyzing phone bill payment history, mobile usage patterns, and traditional credit history, the system generates a credit score that helps bank make informed lending decisions as well. So this strategic framework of K-Bank is designed to position K-Bank as a leader in digital and mobile banking by focusing on customer-centric customization, simplicity, constant availability, competitive pricing, feature-rich mobile banking experience. And the focus on customization, convenience, and competitive rates could be key differentiators in the competitive financial service landscape. And lastly, the fintech model prioritize the user experience by placing the customer at the center, and fintech mobile banking apps may offer a wide range of features, potentially including investment options, budgeting tools, and peer-to-peer payments. And this inclusions of open API suggests that fintech company might leverage open banking practices as well. We can see more telcos are into the fintech as well. And this open API allows third-party developers to create applications and services that can interact with the bank's data, potentially leading to more innovative financial products and services as well. Just a quick update on global 5G evolution, a global 5G community fostering a community and ecosystem around the development of 5G applications. We organize a monthly 5G virtual conference. We are looking for sponsorships from organizations who can support us to sustain this valuable knowledge thought. We have a good followings. We also act as a 5G brand ambassador to speak at organization events, and we can able to collaborate to your business units for any market research advisory in the scope of 5G and beyond connectivity. This is the number, as you can see in the LinkedIn, my personal and the global 5G plus the newsletter, YouTube subscribers. We are very aggressive in our targeting of numbers. We also have our global 5G low Earth orbit community public group. Please do join us as well. And I think that's all from me. So thank you so much. I really appreciate it. And I would like to pass on to our following speaker. Let me introduce Cathy Mao from Massy, France, to present the future seaport. Over to you, Cathy.
Thank you. I'm going to share. Okay. Let me turn into the presentation mode. Hello, everyone. My name is Cathy. I'm going to talk about future seaport today. First, a little bit introduction of myself and my firm, So my name is Mao Xiaomao. That's my Chinese name, but everybody call me Kathy. I have 12 years of radio experience, basically from the field test to advanced technology research. I contribute to the full life cycle of wireless network. Now I'm in the wireless strategic consulting. My goal is to drive the technology forward. I'm from Bell Labs Consulting, so it's a new job for me. My understanding that it's a group of high empathy people with background in information technology, telecommunication, engineering, and economics, law, and MBAs. We team up to help make techno-economic decisions around the world. Now our eyes on Seaport. And also a little bit introduction of our mothership, Nokia Bell Labs. I bet you all know, but just in case, Bell Labs, we innovating and changing the world for the 100th year. We have innovation and invention all around this area, which I'm really proud of. And by the way, we just won the 10th Nobel Prize this year. Okay, I'm going to talk Seaport now. Let's go back to the subject. So the first thing is I would like to introduce what is happening around the world on the Seaport topic. That's what we collect around the world. Like on the left part, you can see a Seaport market prediction that in the next 10 years, we are going to have like $25 billion market for Seaport, for the smart Seaport, like Seaport automation, Seaport digitalization, and also the logistic add-on service around it. And what is the driver for this Seaport market? The market focus on three things: the safety, cost efficiency, and also the more and more hot topic, the sustainability. But what we see from the macroeconomics, that's on the right side, is three main drivers in the macroeconomic supply chain reorientation. China is losing its advantage in the production cost, and now Yes. Hello, can you guys hear me?
Yes.
Okay. No, okay. And the second one is the trade conflict between US and China, because they are fighting. So a lot of made in China goods must be retagged before they shipping to the US. And Mexico becomes the gateway of the MIC goods to US because of its geographical privilege. And also information that Chinese company invests billions of dollars in Mexico just to build factory to assembling their goods like electric cars. And also there's a sea route interruption in the Panama Canal and the Suez Canal. The dry up and accumulation of Panama Canal rockets the transiting expense. And also the traffic through the Suez Canal has fallen in nearly 64% so far this year. And the routine traffic around Africa, Cape of Good Hope, even that it takes like 20 more days for the journey, it's still, we can see the route up of this transition route. Okay, that's what's happening around the world. And we see the driver from the market forecast and also the macroeconomics. And that's what we see. That's what we use as a baseline to drive the developing of future seaport. But let's first see what's the best seaport for now. This is a case study from China, Ningbo Zhoushan Port. On the right side, you can see the profile of this port. It's the top 3 highest throughput port in the world. It has 19 subports area with 620 berths, 100 vessels with 10,000 tons capacity per day. And the project with the motivation of automated ports, and their target is to reduce costs and improve efficiency. The technology involved is 5G, edge computing, AI, and autonomous driving. The suppliers are listed here, and the timeline is that they started the journey in 2016, and it's still continuing. On the left side, we can see that the throughput during 2016 to 2021. It's amazing because they have 6% steady yearly growth, even during the pandemic years. We know that during the pandemic, China has strict lockdown, but even so, there's no interruption. The growth is just steady. This amazing performance of this automated smart port. The first use case they have there is smart cargo handling. The technology is that they basically, install 15 high definition cameras to the crane, and they have on-premise edge computing. They use AI-based vision analysis, to identify the container number, the truck's number, and also the load position and lane number of single containers. They achieve like 95% accuracy and with 1 second latency. We can see the performance is amazing. And the benefit is, of course, we have, they have smooth loading and unloading operation there, and it's totally remote. With this, they have 50% of labor reduction. We should know one thing is that, working at seaport is a highly dangerous career. Like, removing the people from the seaport and moving them remote is actually, contribute to the safety drivers of the market. And the second use case is the remote crane operation technology. They have, still cameras, and they use 5G backhaul and edge computing. What they achieve this, using the technology 5G end-to-end network slicing. It is 8 to 10 millisecond latency and 3.9 reliability. And they, even with this performance requirement, they achieve like 1 Gbps for high definition video backhaul. And the benefit is, of course, we have, they have more agility than fiber and better determinism than Wi-Fi, and also fully remote operation with labor reduction of 70%. And another use case is automated logistic with unmanned trucks. Also the technology 5G, edge computing, end-to-end network slicing, and also Beidou positioning. Beidou positioning is like a GPS positioning, but it's a Chinese private, global satellite positioning system. They have really, really advanced algorithm there. They use a cross-bearing with the base station. So they use satellites and the location of base station to position, the target on the globe. And what they have is automated logistic application. They have the vehicle road coordination, and also they use that to start, brake, turn, and detour and stop the trucks. And the performance that they achieve, the centimeter accuracy positioning. What they have is benefit there is, as it's unmanned trucks, no drivers at all, so it's like labor reduction of 100%, and there's no handover overhead. The last use case is the digital twin with AI edge computing. So they use digital twin accurately reproduce the container handling scenario in Meishan-Dock. Meishan-Dock is just one dock area in the Zhoushan port with a land area of 3.2 million square meters. And the accuracy of this AI model is over 98%. And improving the overall operation efficiency by over 5%. So this 5% looks small, but for such a big port with millions of containers every year, this 5% actually can be translated into a big, huge number. Okay, that's all the use case for the current best port in the world, or the largest port in the world. Then let's see what will be the future seaport. Actually, when I, you can see almost empty slide. When I was constructing this slides for presentation, I was, trying to have one slide to show the architecture of future seaport. Then, the slide turned out to be dry and messy at the same time. It's really funny because then I realized, I cannot have this one slide to have this one architecture, because every seaport is different. The land is different, the requirements different, people's expectation of the seaport is different. There's no way that you have one uniform fixed seaport architecture or model to model this seaport. Therefore, I think that, if the seaport is different, then the network to support the seaport use case will be different. We have to evaluate case by case. So a little bit promotion of our consulting firm. overall, we Bell Labs Consulting help you evaluate the techno-economic, decisions of future seaport and develop your seaport business. Okay, that's all from my side today. Thanks.
Perfect, Katie. That was brilliant. Appreciate that. Really appreciate. Now, moving on to the next speaker, let me introduce Emily Dubs from Geneva, Switzerland, to present when DVB-I meets 5G, optimizing mobile networks for media delivery, new opportunities at hand. Over to you, Emily.
Thank you very much, Ganesh. So I need the right to be able to share. Okay. Thank you. So can you see my screen?
Yes.
Perfect, thank you. So I'm Emily Dubs. I'm head of technology for DVB since the beginning of 2020. And today I present our brand new DVB-I over 5G. That is something that not only enables mobile networks optimization for media delivery, but also offers some new opportunities for content monetization. You've probably noticed that while the 3GPP systems progressively incorporated broadcast capabilities, well, on their side, the main broadcasting standards like DVB and ATSC ones have also evolved towards IP-centric solutions. So I guess you're also aware of some of the initiatives that create synergies between those two worlds. And DVB-I over 5G is one of them. It allows those two systems to interwork at the service layer. So I assume most of you know what DVB is, but just in case, as a reminder, we are an industry-led consortium that is made of the world leading media and technology companies, including manufacturers, broadcasters, network operators, also including regulators. And they all work together to design open standards for the delivery of digital media. You probably know some of our flagship solutions that used to be DVB-TNT2 for terrestrial and SS2 for satellite delivery. Now also DVB native IP for so their IP-based version, and more recently also DVB-I for service discovery. So our specifications are in use in every country. They are normally commercially driven, and they target the maximization of the use of common technologies across all standards. I mean, broadcast, broadband networks, and now also recently including 3GPP networks. So just to set some context, for the past 5 years, nearly 10 years, DVB has focused heavily on IP-centric solutions to facilitate the migration of broadcasters to IP-based distribution. And that's, of course, a really challenge for them, but it also comes with some opportunities if they are able to build on an integrated broadcast IP and even 5G ecosystem. So one of the solutions that was released was DVB Dash for the delivery of services over internet. Then the different market specificities from country to country was an additional challenge. And I mean, the heterogeneous ways for the countries to manage their migration was putting some more challenge, and this gave birth to the now well-known DVB-I service discovery solution, which I'll develop in my next slide. And then DVB MABR for multicast ABR was released to bring scalability to IP networks and to allow adaptive streaming to be used over broadcast networks. And this is why it was also key for the overall DVB native IP solution, that is the solution that allows the delivery of IP content over the existing networks. More recently, an important milestone was achieved with DVB-I over 5G for the discovery of 5G services. This was done in collaboration with 5G Mag, for Media Action Group. And this is what I will focus on today. So first, what's DVB-I, and above all, what it's not? I would say that unlike DVB T2, S2, and etc., that relate to the delivery of services, DVB-I is rather a service layer specification. So it defines the mechanism for the discovery via internet of services that can be delivered through either, well, internet, but also broadcast networks. So concretely, this specification defines the metadata that is used by the receivers to populate their channel list and to retrieve the electronic program guide, known as EPG. The DVB-I services rely on DVB-Dash for their delivery over internet, noting that it builds on MPEG-Dash, but it brings some optimization for a very high degree of interoperability and also low latency, as well as now also targeted advertising. So however, DVB-I services are not only services coming from internet. Actually, any service that can be discovered through this mechanism is a DVB-I service, and it can come from one or several delivery networks, such as internet, of course, but also broadcast, and now also 5G networks. So concretely, DVB-I service discovery allows services that are delivered from any network type, such as broadcast, IP content delivery over broadcast, broadband networks, or now also 5G networks. So those services coming from those networks can be discovered and combined on the end user side into harmonized and sometimes even a hybrid interface. On a hybrid receiver, for instance, so here you can see a connected TV. This will result in a hybrid and unified service list that would also match both the users and the device, the user's preference and the device capabilities. And on a tablet or a phone, so a purely IP device, then you'll be able to enjoy TV-like experience with friendly access to linear services, as well as on-demand services. So in other words, this integrated broadcast IP 5G approach allows operators to adopt a flexible approach, and to use in a hybrid way the most appropriate networks according to cost efficiency, for instance, according to the popularity of services or whether they target high density areas. And this also allows migration journeys to include new networks in the content delivery mix as they become relevant. So now let's look more closely at DVB-I applied to 5G networks. Well, a few years ago, DVB was mandated to standardize the service aspect of 5G. We published some commercial requirements for the support of DVB-I services over 5G networks, with the support that was requested of both 5G broadcast and 5G media streaming. A joint task force was created between DVB and 5G MAG to actually produce a technical report that maps the requirements into guidelines. And this report was also published by ETSI last summer. And it defines DVB-I over 5G reference architecture that's based on which the requirements were summarized in a set of 3 scenarios. So the first one is the support of DVB-I, a service using 5G broadcast only. The other one is DVB-I service using 5G media streaming. And the third one is about a DVB-I service using a mix of both. So for the first scenario, so standalone DVB-I service using 5G broadcast, both the DVB-I metadata that is used to retrieve the services and anything else, so the service themselves, are delivered through broadcast. So it's not the highest priority because, of course, a phone is meant to be connected to a unicast network. However, it's very useful to support this case in case, for instance, the phone has no valid subscription or when the unicast traffic is crashed or not available anymore. Then the second use case is for the support of a DVB-I service using 5G media streaming only. This case is more simple, I would say, than the third one, which is a hybrid mode where, so a typical example is where the XML metadata, so the DVB-I information is delivered through unicast to allow some personalized service list, for instance. And everything else can be either delivered through broadcast, so 5G broadcast, or there are more complex cases where a mix of both also can be used for some services or some service instances. And this is what I'll show you now. Indeed, the support of those hybrid service offerings allows some innovative use cases, and those can be gathered into, I would say, 2 main cases, where, so in both cases, the the DVB-I information is delivered through unicast. However, in the first case, the service is available on both 5G broadcast and unicast, but only one bitrate, so only one dash representation of each instance of the service. So each, would say, combination of a language or a codec and so on. So only one bitrate is available over broadcast, while actually everything else can be available over a unicast. So this allows, for instance, in case of, we can do some session continuity. That means that the receivers by default will consume broadcast content when available, and then it will switch to unicast when out of 5G broadcast coverage. Or you can do some time shifting also, where the content is retained on unicast for a period of time, and then this allows the support of time shift access. In the second case, the service is available on both 5G broadcast and unicast, but some instances of the service are only available through unicast, while all other adaptation sets are available on unicast only. So in case of component replacement, you can do some enhanced offerings like additional languages or improved accessibility features, which could be available only over unicast. Or in the case of content replacement, that means when more alternatives of the content exist via unicast, you can do what we call enhanced venue casting, which is where various video feeds are sent from various cameras, or some dynamic offloading of the unicast networks to the 5G broadcast. So as a conclusion, I would say that DVB-I over 5G allows the LTE-based and new radio 5G networks to carry services with an appropriate and service TV-friendly, service layer, and this is thought to be a prerequisite for commercial success. Also, being able to seamlessly switch between 5G broadcast and 5G new radio, thanks to DVB-I, allows some new opportunities, as we've shown just before. So new opportunities for content monetization, such as enhanced venue casting, which is shown on the left. So it's Dali's suggestion for an illustration for it. And thus we can also achieve some more, so we can optimize the networks and achieve more sustainable delivery. And finally, the interworking of 5G networks with broadcast and broadband ones enable some deployment scenario where the networks can complement each other for their own strengths, and thus also facilitate the migration journeys. So that's it for me. Just before handing over, just not remind, but announce that you can download the paper which I wrote for NAB, which detail or further develop some of the things I've explained today. So you can download it from the DVB event page, NAB event page on the DVB website. Thank you very much.
Brilliant. Thank you, Emily. That was fantastic. Now, let me introduce the next speaker, Ajna Jalim from Johannesburg, South Africa, to present 5G, a game changer for MVNO business models. Over to you, Ajna.
Hi, everybody. I'm actually quite privileged to be here as part of the 5G evolution community. And I would like to delve into a very exciting topic. I'm here just on a higher level to express to you and also to share with you 5G and the impact that it's having on the MVNO business models and the change it's bringing about. So a little bit about me. I am Ajna Jalim. I am a solutions architect with Nix Communications. And you see here, I have written our why and our what. I actually resonate very closely to our why and our what, which actually says that this connectivity for individuals and businesses, empowering brands to provide connectivity and bridging the global divide globally. So our what, some of our products or our main products that we actually offer are Next One SIM. It's a seamless, intelligent mobility solutions for individuals and for businesses. Our Next One Connect, it's a seamless brand connectivity, a cutting edge platform empowering brands to become connectivity providers. and our One Engage. So next, One Engage is a seamless user interface and inclusion and solution, bridging the digital divide. So before we get started, MVNOs, what are MVNOs, and a little bit about them so I can set the base for the understanding. Imagine a world where your mobile experience is so seamless, it's so fast, and buffering becomes actually a relic of a past. This isn't a distant dream, actually. It's the imminent reality of 5G. And for mobile virtual network operators, which are MVNOs, this technological leap is just an upgrade. It's not just an upgrade, it's a revolution, actually. So who are our MVNOs? MVNOs are mobile service providers that do not own their own wireless network infrastructure. Instead, they lease the network capacity from traditional mobile network operators, your MNOs, and then sell mobile services to their customers. This model actually allows MVNOs to focus on innovative service offerings and customer experience without the massive capital expenditure of building and maintaining a network. So here's a fun example. Imagine an MVNO called 5G Evolution, and 5G Evolution doesn't own a single tower, but offers exceptional international travel plans by leasing network capacity from multiple operators around the globe. They focus on providing seamless connectivity with unique perks like no roaming charges and multi-country data bundles, by concentrating on innovative service plans and customer experience. So that's their main focus, instead of actually focusing on the CapEx and the OpEx and the infrastructure. So they are more customer based and not owning the underlying network infrastructure. So that's our MVNOs. Then if we look at the impact of 5G on our MVNOs, it will start with enhanced network capabilities. Let's start with the basics. 5G technology brings ultra low latency, higher bandwidth, and a massive connectivity. So picture this: you are on a video call with your friends in different time zones, streaming in 4K without a single glitch. Well, that's the power of 5G. Latency is as low as 1 millisecond compared to 50 milliseconds on 4G. This transformative capability allows MVNOs to support high-definition video streaming, augmented reality applications, and IoT integrations effortlessly. So think about a virtual reality tour of Lvov from your living room. $5G makes it at the differentiated service offerings that 5G can allow MVNOs to offer. So 5G allows MVNOs to go beyond the traditional. They can now tailor services for specific market segments, consider enterprise customers who need dedicated network slices for critical operations, ensuring security and reliability. On the consumer side, imagine immersive gaming experience that leverage 5G's low latency. For example, if we look at Vodafone's partnership with Hatch to offer cloud gaming services is a stellar example. And by using 5G's network slicing, MVNOs can deliver customized premium services to diverse customers, standing out in this competitive market. And as you can see, we have a sort of a very impactful trend with, as the years going on, we see 5G's impact and adoption is actually increasing in the market share of these MVNOs. If we move on to the next impact, I think Internet of Things would be another. So IoT landscape is absolutely about to explode with 5G. They're capable of handling millions of connected devices efficiently. MVNOs can now develop IoT-specific business models. Picture a smart home with thermostat, security system, and a refrigerator communicating seamlessly. So with this, MVNOs can now offer an integrated IoT package, including connectivity, device management, and analytics. If you look at the automotive sector, connected cars can exchange real-time data for navigation, safety, and entertainment. And the possibilities are actually endless, positioning MVNOs as key players in this IoT ecosystem. Well, one of the main focuses of MVNOs are the customer experience. So with taking 5G into advantage, 5G will now enable real-time data analytics faster than ever, and AI capabilities, which MVNOs can leverage to enhance customer experience. Examples could be while you are traveling with an MVNO SIM, you can say hi to a chat on WhatsApp and communicate with the bot there, rather than actually, communicating to a live agent. This streamlines time. You get your solutions faster. You can actually search on your WhatsApp chat like we have Meta AI. So the things are endless, with in the space of MVNOs and how they can actually enhance the customer experience, limiting any glitches and allowing for a seamless experience on the customer end. If we look at partnerships and ecosystems, to fully exploit 5G's potential, I think MVNOs should engage in strategic partnerships. Collaborations with content providers, tech companies, and other stakeholders will be crucial. For example, if you look at T-Mobile's partnership with Netflix to offer bundled streaming services, exemplifying how alliances can enhance value propositions, actually. So these partnerships can lead to innovative service offerings such as streaming content, gaming platforms, or even smart city solutions. And being at the center of these ecosystems, MVNOs can actually really significantly enhance their value proposition. If we look at the cost efficiency and operational flexibility, around 50% of increase in resource utilization can be conducted, 30% in operational costs, and with cloud native infrastructure, you can actually increase to an 80% service deployment. 5G's advanced technologies like network slicing, virtualizations allow for efficient use of the network resources, lowering operational costs and increasing flexibilities for the MVNOs. As I mentioned, adopting a cloud native infrastructure means that MVNOs can scale dynamically and deploy services quite rapidly. Well, with all magic comes with a cost. So regulatory considerations should be taken very seriously. While 5G offers numerous opportunities, it also brings regulatory challenges. Ensuring compliance with spectrum regulation are quite essential. However, proactive engagement with regulators can open doors to favorable policies and innovation and support. So if you look at the European Union's supportive stance on 5G development, including spectrum harmonization and funding, this illustrates how regulatory environments can actually foster growth. So MVNOs should be prepared to advocate for regulations and foster a healthy competitive market and environment. And then in conclusion, I would like to say that 5G is indeed a game changer for MVNO business models. It offers a unique opportunity for MVNOs to redefine their role in telecommunications industry, and by embracing 5G's capabilities, MVNOs can innovate, they can diversify their offerings and deliver exceptional value to their customers. The future is quite bright for those who are willing to adapt and seize the opportunities that 5G presents. Thank you for the time, and do get in touch with me.
Excellent, Ajna. Thank you so much. Really appreciate, well informed. And let me introduce next speaker, Heikki Almi from Helsinki, Finland, to present on making private 5G agile and affordable. Over to you, Heikki.
Can you enable screen sharing?
It should work now.
Okay. So hello everyone. My name is Heikki Almi, and I'm one of the co-founders of Poutanet. I used to do mobile network architecture at Nokia for quite some time, and our most exciting project there was turning an LTE small cell base station into a consumer product. And This was not our idea, but Facebook told us in the early days of the telecom infra project that, look now guys, the way that mobile networks are built, it's very old-fashioned, it's very expensive, as it requires a lot of expertise and manual work. And Facebook basically told us that we could do better, and we decided that we will give it a try. Over time, Nokia lost interest in this topic, like in many other topics as well. So we decided to continue on our own and founded Poltonet. So Poltonet is for simple mobile networks. The only addition to the original ambition is that now we are not just turning the base stations into consumer products, but the entire mobile network, which means that we are focusing on private networks. And okay, now who needs these kind of networks? Our biggest customer base today is folks who bring payment terminals to events where there's a lot of people. So in those festivals, public networks get congested, and building a Wi-Fi covering a large area takes a lot of time, and it's very, very error prone. And with private mobile network, you can set up your service in 20 minutes and then start operating. And when you're done, you need another 20 minutes for packing it all back into the box. And so far, this has been mostly 4G, but digital payment is not very data hungry. But now add video, and we have the use cases for temporary small private 5G networks. And let's see if we get to the next slide. So today, broadcasting is driving this topic. So if you're a broadcaster and you have to cover an event in a place where there's no fixed cabling or for cameras, it's quite time consuming to set up the systems. And again, it's very error prone. So wireless is much more convenient. For example, a smaller sports tournament or an orienteering event somewhere in the forest, these are good examples. That is sort of nightmare with handling with traditional technology. Another use case is live TV interviews. So if you have a parliament, you have those heated debates over some new legislation, and then all the party leaders come out and want immediately to say something to their favorite media. And now, usually, the way how this is done, the transmission of the live streams is by a number of cellular modems that are packed next to the video codec, and then the traffic is sprayed into all available mobile networks. And this may work well if you live in a two-party system, but if there are 4 or 6 or more party leaders who want to have their interview at the same time, then it's sort of quite likely that the interview freezes mid-sentence, and the news anchor apologizes and continues with something else. In this use case, the actual coverage area is quite limited, and it's indoors. And you could argue that, hey, let's do this with Wi-Fi, it's much cheaper. But the tricky part with Wi-Fi and media is that you are on an unlicensed spectrum, which means that when you have several camera crews and all the additional journalists around with their wireless gear, it's highly likely that you will have interference, and again, there is high risk that the live interview is cut short. So back to the festivals, at least in Europe, the requirements for safety and security have been tightened quite a lot in recent years, and now security cameras are increasingly required. And like for media, the fast setup and no interference is sort of a basic requirement, and that's where 5G has an edge compared to other alternatives. And requirements for people like emergency response are also quite similar. So you would like to take your network along with you to the forest fire and have it operating in 0 time, and then you do your job, and when you're done, you pack your stuff and return to base. And let's move on. And this is basically the simplest incarnation of private 5G. And it's this is actually built for this parliament scenario. So you have a small server or semi-industrial PC running the 5G standalone core, and we prefer to have there also a local management portal. And then you have an indoor GNB and maybe 2 or 3 if you need to cover a bigger area. UEs are camera encoders with modem and a private network SIM card. And, okay, you may want to put some of these private network SIM cards also in your regular phones in order to access that management portal and see where you are with your network and how it is doing. And it's good to note that in this setup, all the 5G functionality is on site. So it's only for the application that you need an internet connection if you need one. So of course, if you send several stable 4K video streams, you should make sure that you have some hundreds of megabits capacity reserved for connecting with your studio. But we also have a customer who is remotely operating a forestry machine that is cutting trees. The operator sits in a trailer that is parked at the roadside, and inside you have a joystick and a large screen, and all the video needed for controlling the machine safely is actually consumed locally, and no internet connection is needed at all. So this is actually a use case that is pretty close to the smart cargo that Katie explained earlier. But if you have this forestry application, then you need to have somebody close to the machine, as every now and then you need to fill in gas or oil and to do this sort of practical maintenance that cannot be automated yet. Okay, but if we want to make this high tech, here is an example of how to stretch it a bit and to make real use of some of the more advanced 5G features. So this is sort of unique in the sense that this is 5G only. So in a setup where you have a camera crew with several cameras, for example, sending live stream from a concert, like in the picture here, you have locally the mixer who decides what camera stream is actually broadcasted. And by selecting the stream, the mixer actually invokes a 5G application function that requests from the mobile core higher priority for that particular camera. So with this arrangement, you can make sure that the stream that goes out is always 4K or whatever the high quality video is that you want to be distributed. And that's basically disregarding of how many cameras you connect to the system. Okay, so so far most private mobile networks have been built in a very traditional project mode. So it's planning and contracting and still more planning and rollout and maintenance, and then in 5 years' time you repeat the process, and that's quite expensive and rigid. In order to make it easier to build small and affordable private networks that can be extended and modified in a say agile way, it would be good to have a few options in the standards that allow building and operating private 5G, basically like Wi-Fi on steroids. So on the slide you have my wish list to Father Christmas or to 3GPP, whichever you would like to think of. Number one, I think SIM authentication is a relic that has been guarded by the operator community for long enough. So the basic concept is from the 80s. Operators wanted to have a SIM in GSM for unbundling the subscription from the handsets, and those days some of the UEs had notoriously poor security, and the result was identity thefts and all sorts of trouble that operators needed to sort out, and they didn't want to have this again. But now everyone has forgotten, and when eSIMs are sold to the UEs, we are basically back to the original setup, and let's hope that nobody hacks say the eSIMs used in iPhones, for example. So I would like to have asymmetric authentication as an alternative to SIMs. This would actually allow moving the centralized subscriber database. And for us, if we build these small mobile networks, that subscriber database is the most important part of the mobile core. And if we could have the subscription in the mobile, this would allow us to do a lot of cool stuff. Like as a user, you could connect to a base station and negotiate with that base station what kind of service you would like to have today. So we have actually some working code on that. And once the SIM is made optional, we could, in small networks, keep the rest of the core as well. If you think about the security camera mounted on a wall, there's not much use of mobility management or a mobility anchor. And for a sensor connected to a 5G LAN, the need to run the traffic through a UPF is outright counterproductive. The base station is certainly located in the same factory hall where the target LAN is, where you want the traffic to go. But the UPF is not, unless you place a lot of extra boxes around your factory, and that solution comes with a lot of strings attached. Then spectrum sharing or local licenses, it's a key topic for enabling private mobile. And without any standards, many legislations, most of Asia Pacific and Africa, for example, are not doing anything, which means that the private network business is left to the mobile operators who have licensed spectrum already. And well, this may be good for those operators, but definitely not for agile and affordable private networks. And okay, then is my plea. Botanet is too small for going alone to 3GPP and fight for these topics. So if you have the muscle and if you are interested in driving some of these, we are happy to help. And, this concludes my presentation, and please join me on the journey towards simpler mobile networks. Thank you.
Fantastic, Heikki. Thank you so much. Appreciate that. Let me introduce Zanab Sadka from Stockholm, Sweden, to present towards integrated TSN 5G networks. Over to you, sir. Would you mind to unmute yourself?
Oh, thank you, Ganesh. Can you see my slides? Great. So yes, hello everyone. My name is Zanab Sadka. I'm a PhD candidate at Mälardalen University. Today I'm going to represent one of our projects that we have at MDU, which is basically focused on the integration of time-sensitive networking with 5G networks. As a university, we do research, but we have a close collaboration with the industry. And in this project, we are basically collaborating with Arcticus Systems, Hiab, and Volvo Construction Equipment in Sweden. Our research goal is mainly to develop new techniques to provide an end-to-end quality of service mapping and traffic forwarded for a converged TSN 5G network for predictable communication. As you can see, we are focusing on predictable communication, meaning that we are aiming for determinism and to achieve these bounded low latencies with high reliability in real-time applications. To understand more on the focus and the scenarios that we use, let me describe or share a future vision scenario with you. As you can see, this scenario, I'm sitting comfortably in a self-driving vehicle, which is seamlessly connected to the other vehicles to navigate the streets. Everything is in perfect harmony with no traffic jams or accidents. My vehicle is communicating with other vehicles to adjust the speed and the position. I can relax and enjoy the ride, knowing that my journey is secure and safe. I can see that the vehicle is able to avoid obstacles and hazards. It is also connected to the network. introducing me with real-time information and different types of entertainments. In this scenario that I described, there is a lot of communication ongoing here. These type of communications are included in the vehicle to everything communication from 5G side. You saw that my vehicle was connected to the other vehicles to share information and also to adapt the speed and to optimize the traffic flow. This is basically includes the vehicle to vehicle communication. On the other side, my vehicle was connecting to the infrastructure. It can find the parking slots or also the charging slots in the area. Also, it is connected to the network, providing real-time information, as well as different types of entertainment from the network. And it can also adjust the speed and stop smoothly when pedestrians pass the road. So in this type of scenarios, as the most promising candidate that we have nowadays stands the 5G networks, which comes up with network speeds up to 10 gigabit per second, latencies, here we talk about communication latencies as low as 1 millisecond, ultra reliability, as well as higher bandwidth. I won't stop in these small videos. I'm sure everyone knows these features of 5G. But on the other side, what was happening within the vehicle? We have to know that there is a lot of data transmission ongoing within the vehicle from different sensors, lidars, or cameras. And there are also different types of network coexisting within the vehicle, like Ethernet, CAN, which is the oldest one, FlexRay, as well as the newest or the extensions versions of Ethernet, which is Ethernet AVB and Ethernet TSN. Our focus is on TSN, time-sensitive networking. So firstly, Ethernet has been the backbone of IT infrastructure for more than 40 years, but it was never designed to be a deterministic network. That's why over time, Ethernet standards have evolved to address these low latency applications. More recently, we have seen AVB, audio video bridging, as well, which was changed to time-sensitive networking. Time-sensitive networking is a wired network, so it is restricted only for onboard communication. It is introduced as an extension of Ethernet with the aim to improve the communication by supporting time-triggered transmission. Now, looking at the figure, you can see different type of data coming from different sensors, one from tire pressure sensor and the other one from collision detection sensor. The data that is sent by the collision detection sensor is a high critical data. And for this type of data, we need to send them with some bounded low latency over the network. But we also have on the same network or on the same system, we have data that is coming from other sensors, which is not highly critical. So what TSN does is that it ensures that over time, it will always guarantee or make sure that the data that is coming from high critical sensor will always be transmitted first on the network, and it won't be preempted by other low critical data. So this type of application is, in this figure, I'm taking the example of airbag, which is a real-time application when you want to transmit this data at exact time, so not too late and not too early, which means that we need these bounded low latencies for this type of data. And TSN can ensure these guarantees. So why do we want to integrate TSN with 5G? Basically, the previous speaker actually introduced this scenario, which is the remote control of a vehicle inside the forest. So inside the forest or in areas where the cable connection is not feasible, we want to add the flexibility of a mobile connection. So therefore, we want to introduce 5G to enhance these features of TSN and add the flexibility connection. And the 3GPP introduces this integration while by having 5G as a logical TSN bridge. This is the most promising approach. Basically, the basic idea is to create a black box model where the 5G system appears as a TSN bridge to the outer TSN network. But it uses, internally, it uses its own framework to transport the TSN frame. For a full integration into the TSN network, the logical 5G bridge has to support this transmission of Ethernet traffic with MAC addressing, and also it has to differentiate traffic with some guaranteed services. These first 2 points are part of having a gateway basically between both networks, because here we are converging those networks in, and they have to kind of understand each other in the way how they treat different types of traffic with different quality of services. And the TSN network works on the priority basis, while 5G works on quality of service basis. Moreover, another challenge on this integration is the time synchronization between both networks. As we are focusing on real-time applications, we really need the time synchronization of both TSN and 5G. And lastly, 5G needs the support for TSN management and configuration, which is again another challenge on that side. There is a lot that I can talk on this integration, but the time is limited. I would like to thank you for attention. This is a list of some of my research papers. If you are interested in this topic, I would kindly ask you to check the papers and even send me an email if you would like to collaborate with us. Thanks a lot.
Fantastic. Thank you, Zainab. Really
Thanks.
appreciate it. Let me introduce the next speaker, William Strova from Brittany, France, to present on 5G for media streaming, in particular for the usage of multicast and broadcast technologies. Over to you.
Nice. Hopefully you can hear me.
Yes.
Okay. So okay. Hello, everyone. 5G represents a set of technologies that are transforming the mobile communication and creating new opportunities for business transformation in our digital era. Media streaming business is in itself going through radical changes brought by the flexibility of OTT video, cloud technology. In this presentation, I'd like to discuss how 5G can contribute to help the video ecosystem to thrive. My name is William Stover, and I have been working in the media and entertainment sector as well as the telecommunication sector for the last 15, 20 years. I'm an expert in product management on telecom and media and entertainment. Video consumption over mobile network is poised to grow significantly. As we can see here, the video traffic is expected to represent 80% of the mobile traffic, mobile data traffic by 2027. That is to say, 230 exabytes of video data traffic per month. So this massive increase is directly related to new applications in the video landscape that you might have heard of, like, for example, ultra high definition video, 360 immersive video, or AR and VR applications. This represents an important opportunity for mobile network operators, broadcasters, and content providers, successfully delivering good quality video to hundreds of thousands or even millions of end users for an optimized cost and having a satisfied end customers. This is why I think leveraging the tools provided by 5G to distribute content in an efficient manner are going to be, from my point of view, of the highest value in the coming future. Let's take a look at the some of those tools and what they can offer. 5G offers several mechanisms that can be exploited, that can be leveraged to create business value out of the content delivery. First of all, there is 5G media streaming architecture, which is a standardized end-to-end architecture and a set of APIs defining from the core network to the user equipment a series of procedures to deliver the content efficiently. Secondly, there is 5G MEC, or multi-access edge computing, which allows to save traffic in the core network and reduce latency, response time for a better quality of service. Third, there is the 5G broadcast and the 5G multicast broadcast, or 5G MBS family of services, of tools for optimizing the content delivery by reducing the spectrum usage while delivering to theoretically any amount of end users. And there are several other functionalities, such as the 5G APIs promoted by the CAMARA group from VSA, offering application providers an easy way to interact with the 5G network to request, for example, a certain quality of service, or the slicing mechanism that have been referred before, enabling the MNOs to create virtual private networks that are going to guarantee the levels of quality of the use case they were created for. Okay, let's not lose any more time. Let's take a quick look at the 5G media streaming architecture. The 5G media streaming architecture is described in 3GPP 26501. This architecture supports uplink and downlink, uplink and downlink streaming services owned either by the MNO or by a third party. The architecture describes related network and UE functions and APIs for handling services such as video remote production or video distribution. In this presentation, I will be only focusing only on the downlink aspect of the specification, on the distribution side. So the 5G MS supports CDN and head-end application in a content delivery use case. They are known as content hosting and content preparation blocks in the specification. They are in charge of the adaptation and caching of the content to be delivered efficiently to multiple clients in different network conditions. For example, delivering the same content to thousands of devices, including TV sets, Apple and Android smartphones or tablets, using, for instance, ultra high definition, or standard definition video at different bit rates. The architecture provides support for provisioning the sessions by the MNO or a third party, and it can automatically adapt to deliver depending on the network resources availability and conditions by dynamically negotiating with the policy and charging function. It provides as well resources to log the quality of experience metrics for further analysis. Another important fact is that another important fact I was saying is to point out is that the NEF, NRF, and PCF blocks are going to handle the application running in customer devices interface with the 5G core network. This specification describes as well the implementation of 5G broadcast and 5G MBS, or multicast broadcast. So let's describe what 5G broadcast is. 5G broadcast is a technology that was issued from the former EMBMS or LTE broadcast, starting back in the release 9 of 3GPP. It was first adopted for the use of broadcasters since release 14. The work was then improved in release 16 in what was called the enhanced TV. And later, a year ago, 2023, there was an addition of broadcast bands 107 and 108 that are mentioned here. This download-only technology, it only support downlink, defined to efficiently deliver content in broadcast mode. Users would not require a subscription to an MNO, right? Because they can receive the content in free-to-air. By the way, this is probably one of the main business blocking points, because for the mobile device vendors, their customers are essentially MNO. And now we're saying there is no need to subscribe to MNOs. So it's difficult to motivate them to make changes to the devices to support 5G broadcast in this context. This point will certainly require negotiations between MNOs, broadcasters, and mobile device vendors in the future.
Williams, sorry, the time
yes,
has already surpassed 15 minutes. So would you mind to quickly wrap up?
Okay, it's already 10 minutes.
Yeah, it's already more than.
Okay. So yeah, I was, okay. The other technologies that I wanted to cover was 5G MBS. 5G MBS is using basically the same basic protocols that were defined for 5G broadcast, like for example, the Bluetooth protocol. But in this case, the delivery of the content is made by the MNO. There is 5G MEC as well that is used in order to make applications to run closer to final users, to reduce latency and reduce the delivery of the bandwidth needs in order to deliver the content to the final users. And you can use it in a very dynamic way, because you can assign resources in a distributed manner, in different MECs, depending where your traffic is. The use cases that can be deployed for leveraging the 5G tools that I have mentioned are, I wrote down 3 here. Fixed wireless access, to have MNOs to compete with fiber ADSL cable, and to deliver fiber-like video services everywhere. We can imagine in-venue media services as well, deliver multiple angles to the attendees of the game. There is car entertainment, for transforming the cars into living rooms, for instance. I'd like to say, as a conclusion here, that MNOs, broadcasters, and CPs can now leverage 5G to embrace this 5G video streaming opportunity. Here we have a technology that will help them to deliver high-quality content with controlled cost. New business models will have to be created to foster collaboration among those stakeholders. So thank you very much for listening. And that's it for me.
Fantastic, brilliant presentation. Thank you, Williams. Appreciate that. Let me introduce Adel K from Riyadh, Saudi Arabia, to present on cloud migration strategy and application to IT and telco workloads. Over to you, Adel.
Yes, thank you. Thank you. Let me just the content. Okay. Okay. So as an introduction, I'm Adil Ksuha. I'm telco network core and cloud architect. I'm based in Saudi Arabia. I'm working with SSC in the strategy and architecture sector. I will be presenting in this presentation. I will be showing how we can go to the public cloud from telco and IT point of views. Just for a reminder for those who are just new in the topic, so there are several use cases where a customer or a telco operator, whatever, who want to move or to go within to host his applications and to grow within the hyperscalers or to cloud in general. There are 4 use cases. We have the expansion model, where you have some applications and you want them to you want to expand those applications, or you want to expand your data inside or within the hyperscaler. You have resiliency where you have one site, for example, and you need some kind of resiliency, HA or just DR. The third case, it is the migration where you have some applications and you want to move some other applications because you have done your calculation and your assessment, your business case, and you found that it's better to host them on the hyperscaler, on the public cloud in general. The fourth case, it's when you have some legacy applications and you found that those applications need to be modernized, especially that you have some new services to be included, some new capabilities to be included. So one of the ideas is to go to modernize and go to the hyperscaler. To understand first, before the idea is to, before going to a solution or before explaining how we can find a solution or find a approach to resolve an issue, we need to understand the as is, and we need to understand all the issues that we have now. Generally, for a customer who is hosting his applications on the private cloud, generally he is having a capacity oversizing due to the application demand. Some of the application you don't know, especially if it's the application, it's a public application, it's a web as a front web application, it's a web which is receiving requests from the external, from the internet, for example. You cannot control the capacity. So based on that, so the customer is obliged to invest on the part which is related to invest on the on more capacity. You have also extra long time to market. So most of the customers, generally small or medium, based on the market, based on a supplier, sometimes it takes so much time, long time to deliver his infrastructure, to design, to build, to accept all the infrastructure that we have installed, and to go to the day two operation. You have multi-vendor management in a private cloud. So you have virtualization, you need to manage the virtualization, you need to manage the Kubernetes, for example, for new use cases. You need to manage your storage, your service, networking, security. So all of them, they have different vendors. You have, for the virtual silos, when you design your environment, you have pressure to put different clusters. You have clusters per license. Some license, for example, Windows, Oracle, Red Hat, whatever. You have a cluster for application type. You have database. You have front end. You have back end. You have clusters per performance. You have some application will need more performance. Some application will need more powerful service. Some application need just normal service. And you have also license model change. You need to manage that, because some of the vendors, essentially the case of VMware, they have started to change their model from perpetual to subscription. For they also go into the public cloud. It's not something it's challenging. The first thing that we should mention here is the cost management difficulties. So you need to manage your cost based on CPU core, based on storage, based on API requests, based on throughputs, based on performance, and so on. You need to have some skill set. You have to need to recruit some teams, not one or two, but teams of people who have all the skills based on all hyperscalers. If you are willing to put your data, your data of your application, or to host your application on different hyperscalers. You have also integration complexity, because when you put the application on the hyperscaler, you are not sure which kind of service you will be using. Sometimes you need to integrate with all type of services provided, the monitoring service, the security service, the compute service, the storage service, and so on. Telco performance also, from telco performance point of view, we'll have a slide for that. You have some performance requirements related to low latency, high throughput, and so on. So you have higher price compared to on-premise, because if you compare one to one, apple to apple, for sure, the hyperscale will be higher in terms of the pricing. And you have also concerns about data privacy and security control. Sometimes of some hyperscalers, they had some security breach which have been published recently. And data privacy, it's you need to control your data, where your data will be hosted on the local public cloud or the remote public cloud. The general migration approach, we have 4 general migration approach. We have lift and shift, replatforming, refactoring, and SaaS. Lift and shift, it's when, for example, you have an infrastructure and you have the idea, I don't need this infrastructure anymore in my data center. I need to move. So I just move one shot the application, put them on the public cloud without doing or doing just minimal changes. Replatforming, it's when, for example, you have databases and you want to use the cloud databases, or you want to change the cloud stack, or you want to add more feature on that. So you can go to the you can use the replatforming use case or approach. You have refactor. It's you have an application. This application, it's monolithic, it's legacy, and you want to transform this application. So you need, for example, to go to a microservice based, containerized based on Kubernetes, for example. You want to update your code source based on the security, because you will be integrating with CI/CD pipeline. So you need to have secure code, secure image, and everything. So this kind of refactoring is something which is huge, which is time consuming, it is effort consuming, it is costly, but in the end you will take the advantage, you get the advantage from the public cloud. And you have the SaaS. The SaaS is it's costly, but you need to move your data and your business logic without moving anything, which is a little bit simpler compared to the other approaches. The public cloud migration best practice. This slide will be focusing on the IT part. So one of the recommendation based on the experience that we have on different projects, and it's the first thing is to start with cloud fit, which means that we don't move any application which is not fitting with the cloud. The cloud should be a solution when it is fitting there. If an application will be resource consuming, when application, it will be costly for you. It will not, you cannot manage the scale. It's somewhere you need to master this area before going to the cloud. Always simple architecture, always that. Don't go for complex architecture. Complex architecture which leads to failure. It will lead to higher cost. Regional versus local availability. It means that you need to think about the hyperscaler who have like regional presence. Like in one country, he can have different regions. It's better for you because you can have better availability. Long-term commitment. If you go to the hyperscaler, it's better to think about long-term commitment. You need to look to the SLA and SLO. Some hyperscaler, they have strict SLA and SLO. If it is not fitting with your business, is not fitting with your application, will have drawback, will have an impact on your business in the future. Data gravity, your data need to move with your application. If your data it is in on-prem, for example, and you move your application to the hyperscaler, there will be some cost there. There will be some impact there, some design challenge. And also the final thing I say here, it's innovation. Don't go to hyperscaler only if you have in mind innovation. If it is just cost optimization, it will be challenging a little bit. But if you think about using the resources and using the services in the hyperscaler, it will be better. During the migration, you need to follow a gradual migration, step by step. Need to implement auto-scaling policies. You need to implement data storage policies. You have storage. We have storage which you need to have a fast and frequent read and write. We have storage. We have data which you need to fetch the data only once per month, or once per 3 months, or once per year, or maybe more than that. So you need to play on that. Use preemptible VMs, which means that VMs that run for a certain time, like 24 hours, and they are deleted. This is also good for you from cost point of view. Keep on-premise sometime. If you are not willing to keep the on-premise, so you need to keep it for some time until you have some stability in your cloud, and avoid going to multi-cloud from the beginning, because it will be very challenging for you. After the migration, implement FinOps best practice. It means you need to control your bill. Keep an eye on your existing strategy. In exit strategy, you are going to hyperscaler, but you need to know that one day or any change that will happen on the hyperscaler, you need to be ready for that, to move from that hyperscaler to another hyperscaler, or to return back to the on-premise. Keep an eye on your business case, because you have done for sure a business case. Build the COE, which means Cloud Center of Excellence. You need to have a team to do that. Reassess your sizing after the migration. Go into the telco cloud constraints. Telco cloud constraints, some of us, know about the telco cloud constraints. Telco cloud constraints, it's something related to communication.
Yeah. It's already more than 12 minutes. Would you mind to wrap it up, please?
Yes, I think less than that. I think I'm okay. It's 9 minutes, I think.
No,
okay.
It's 12
minutes. Okay. So to wrap up, so telco, we have some telco constraints related to communication between virtual machines and inside, outside. You have ultra high throughput, hypervisor level acceleration, network card acceleration, resource isolation, and so on. So CX, for example, you need to have CX, customer experience, traffic segregation, all of that. This is some constraint in telco cloud. You have also application level constraint related to the architecture of Mano. You have also network performance. The telco application does not support auto-scaling. You have extensive egress and ingress traffic. You have traffic spike, and also you need to have function certification. So the final slide is to talk. This is the recommendation. Always, if you want to go for a telco application, or want to go to telco cloud, you need to choose a certified vendor on the telco cloud. Choose MVNO, MVNE. This is the easiest way as a greenfield. Choose a public cloud with multiple availability zone, brownfield. Could be a DR. You need to plan on your traffic based on traffic model. Network slicing is the best use case, and also you need to use the edge use cases. You can consider edge use cases. Final thing, it's when going to telco cloud, you can use the public cloud. If you have a central site, you can use your UPF, for example, in regional sites, and also in the edge site. In the edge site, you can use your ORAN UPF, but this depends on the availability of the public cloud. You need to make sure, or you need to consider that there will be extensive traffic between all the different type of sites. I think I finished. Thank you so much.
Great, Adel. Great. Very well explained. Fantastic. I really enjoyed it. Thank you. And the next speaker, introducing Zainab Mohammed from Riyadh, Saudi Arabia, to present on Unlock the Future with IoT, IIoT, and 5G, transforming industries and shaping the connected world. Over to you.
Thank you, Kanish, for introducing me. Let me share my screen now. Okay. Thank you, Adel, for the wonderful insights about cloud migrations. So greetings, everyone. Thank you for being here today. My name is Zainab Mohammed, and I am an IoT product manager at Mishkati Solutions. Today, I'm excited to present to you on a transformative topic, unlocking the future with IoT, IIoT, and 5G. So over the next 10 minutes, we will dive into how these groundbreaking technologies converging to create a smarter, connected, and sustainable future. So let's begin. About today's agenda, we will talk about the rise of the Internet of Things, industrial Internet of Things, 5G as the enabler of IoT and IoT. Finally, challenges and considerations. To start, let's discuss the Internet of Things, or IoT, which signifies a significant shift in how we currently and will interact with the world. Just imagine a world where everyday objects like refrigerators and streetlights are linked to the internet and to one another. The network of billions of interconnected devices can gather and share data, leading to unprecedented level of automation and intelligence in our surroundings. So, for instance, in our homes, IoT enables smart devices like thermostats that learn your schedule to optimize energy usage, or refrigerators that can notify you when you are low in milk. This connectivity extends beyond personal convenience and into industrial settings, where IoT enables machines to communicate with each other, leading to more efficient and reliable operation. This revolution is not just about convenience, it's about creating systems that are more efficient, sustainable, and responsive to our needs. Just let me, yes. So about industrial IoT or IIoT, building on the foundation of the Internet of Things IoT, let's dive into industrial counterpart, the Industrial Internet of Things IIoT. This revolutionizes industries by integrating advanced sensors, data analytics, and automation technologies into industrial processes, offering several key benefits. Firstly, IoT enables smart manufacturing by allowing factories to operate more efficiently through real-time monitoring and automation of production processes. Even machines can self-diagnose issues and even order maintenance before a problem causes downtime. Secondly, IoT facilitates predictive maintenance by using real-time data to schedule maintenance exactly when needed, reducing cost and preventing unexpected downtime. Lastly, IoT provides optimized supply chains by offering real-time data from sensors throughout the supply chain, providing insights into logistics, inventory levels, and demand patterns, enabling more responsive and efficient operations. So 5G as the enabler of the connected world. Now let's discuss the technology that serves the backbone for both IoT and IIoT, the 5G. At the Exchanging Ideas 50 Global 5G Evolution event, we are exploring the role of 5G technology as the enabler of this connected world. 5G offers lightning fast speeds and ultra low latency, making it essential for applications requiring real-time data exchanging and coordination. As in healthcare sector, 5G supports telemedicine applications by enabling remote patient monitoring and robotic surgeries, allowing doctors to perform procedures from across the globe with precision due to the low latency of 5G networks. Also in transportation, as Zainab said, 5G empowers autonomous vehicles to communicate with each other with traffic infrastructure, enhancing safety and reducing congestion. Additionally, smart cities benefit significantly from 5G as real-time data from devices can optimize everything from energy usage to public transportation, creating more efficient and responsive urban environment. It's also about customers, so customer-centric innovations beyond operation efficiency. IoT and 5G technologies also significantly enhance customer experience by engagement. And how is that? By gathering real-time data on customer preferences and behaviors, so companies can provide personalized interaction and proactive customer service. For example, smart retail solutions can analyze data from in-store sensors to understand customer movements, patterns, and preferences. This allows retailers to customize products, placements, and offers in the retails. Also, in the realm of customer service, connected IoT devices can automatically detect and report issues, leading to proactive support interventions. So before customer even realize there is a problem. And this is not only the case, also also 5G facilitates immersive, augmented, and virtual reality experiences, enabling customers to interact with the products in a digital environment, providing a more engaging and a lifelike experience. So about the it's also about the sustainability and the environment. So how 5G make eco-friendly solutions, in addition to improving efficiency and customer engagement, it's important to highlight the role of IoT and IIoT promoting sustainability. These technologies enable the development of eco-friendly solutions and help reduce the overall carbon footprint. For example, the smart grids powered by IoT can optimize energy dispersion, reducing waste and improving efficiency. We all talked about the 5G as the enabler of all the technologies. Also, there is some challenges addressed. Despite the numerous benefits, we must also address the challenges associated with the widespread adoption of IoT, IIoT, and 5G technologies. First, there is the issue of privacy and security. With the proliferation of connected devices, the risk of data breaches and cyber attacks increases. Also, robust security measures and regulatory frameworks are essential to protect sensitive information. Secondly, infrastructure investment is a significant hurdle. Deploying 5G networks and ensuring connectivity for vast number of IoT devices require huge financial investment and coordination. So additionally, there is a need for specialized talent, as Adil said, talent and expertise to design, implement, and maintain these complex systems. So by addressing these challenges requires strategic planning, collaboration, and continuous innovation. Okay, so to recap, or in conclusion, as we harness the transformative potential of IoT, IIoT, and 5G, we are on the brink of a new era of innovation and progress. These technologies will enable us to build a more efficient, sustainable, and connected world, reshaping industries and enhancing our daily lives. So thank you all for your attention. I'm open for any questions at the end of the session. Thank you all. Thank you.
Well done, Zainab. Thank you. Appreciate that. Thank you so much. And
Thank you.
let me introduce our last speaker, Eric Davidson from London, UK, to present the topic of satellite IoT, its position as a connecting solution for the IoT, where we are and where it is going. Over to you, Eric.
Thank you very much. Let me just... We okay? Can see that? Okay, so it's my name's Eric Hewitson. I work at a company called Wild Networks based in Cambridge in the UK. And we specialize in connecting the Internet of Things via low Earth orbiting satellites. So this is a technology that has really developed over the last few years, and it's just really still at the very beginning of its journey, in my view. And the principal enablement of this technology is that by connecting anywhere on the globe, you can connect IoT devices anywhere on the globe. So it means even in very remote areas, you're still able to collect data and build up data. So a couple of things about low Earth orbiting satellites just to get started. So they're generally about the size of a shoebox. they're in orbit it's sort of between 500 and maybe a couple of thousand kilometers up in the sky. So generally around sort of 600 or 700 kilometers up in the sky. They're traveling at about 25,000 kilometers per second. So they rotate around the Earth about every 90 minutes, roughly speaking. And as the Earth rotates beneath it, it's on its natural rotation. So the satellites kind of map out the whole of the globe's surface. And over the course of a single day, over a 24-hour period, one satellite will basically be at some point be above every point on the Earth's surface. And this gives you the opportunity to connect sensors from the ground up to these satellites. And in this field here, you can see some soil moisture sensors. So in the ground will be a probe that's collecting data from the soil moisture, the soil temperature, those sorts of values. But how do you get those values into the internet if you're outside of cellular range, or if you are in some remote location where there's no power and there's no other connectivity service? And this is the big problem. So currently only 15 or maybe perhaps as much as 20, but it's probably nearer 15% of the Earth's surface has cellular connectivity. So that obviously means 85% doesn't, and we're looking to address that 85% of the world's surface where there are a lot of activities going on, even if that's not where most of the humans are living. There's, I think McKinsey's predict that there's about a $3 trillion global boost to be had if the problem of this connectivity in the 85% of the Earth's surface can be solved, by 2030. So, there's a massive opportunity available. And as I said, the key bit is the fact that these satellites have got 100% global coverage. There is a massive demand, particularly from verticals such as agriculture, utilities monitoring, energy sector monitoring, renewables, environmental monitoring, shipping, obviously maritime, and logistics. So these are all the areas where there's great opportunity to connect IoT devices and sensors to low Earth orbiting satellites. One of the key things is that they are sensors that are low power can be run with satellite connectivity also at low power. So you can do a lot of these things on very, very low power, which means makes it possible to leave sensors in the field, able to connect to satellites, and you don't have to kind of maintain them or do very much to manage them. They can go for years on 2 AA batteries, or indefinitely if you've got a solar panel and 2 AA batteries. And this way you can obviously boost operational efficiency, lower costs, reduce inputs, be more sustainable. So this is a look at what the ecosystem looks like. So this is the end-to-end ecosystem of an IoT environment using satellite IoT. At one end, you've got the sensors doing whatever they're doing. So it might be temperature, humidity, grain monitoring. There's a lot in agriculture: grain monitoring, soil monitoring, nitrogen runoff into fields, well monitoring, lots of things around water, pressure in pipes, cracking on pipes. Any kind of piece of fixed infrastructure or asset could possibly be a good opportunity for satellite IoT. There are currently many terrestrial networks for the IoT, where gateways are set up and multiple sensors are speaking to these gateways, and these gateways then feed back into the internet, and that's a fantastic thing. But where you're going into wider areas, it sometimes becomes completely economically unfeasible or technically unfeasible for the people working in those areas to maintain those kinds of networks and those gateways. There may not be power, there may not be any way to get the information back into the internet because there's no cellular or Wi-Fi or whatever it is. So there the key thing is this choice of being able to go either one or the other, or a combination of both in a hybrid kind of model. At some point you need to get your data into a data management program, where you can upload your sensors, where you can onboard your sensors, where you can see the data coming through, etc. And then ultimately that data needs to go out to an analytics platform or an app of some sort, because all of these sensors may be very, very technically sophisticated. I mean, we're a connectivity company, so we don't know that much about soil moisture monitoring or what it means when you're growing a particular crop. So you have to have specialist analytics platforms for those things as well. So it is an ecosystem of different types of companies working together. This rather boring slide I've just put just briefly to say there are different types of connectivity, and obviously we've been talking about 5G a lot today. So 5G NB-IoT is one of these low power connectivity solutions or technologies, protocols that you can use, but other popular ones, L-band, S-band, and LoRaWAN as well, LoRa. And so just finally, just to give you an example of a project that we've worked on. There are many I could choose from, but this is one example. This is actually in a date plantation in Namibia. So the plantation owners were looking to optimize the water supply to the plants, and to you know, it's partly to reduce the amount of water using, because obviously water is a precious resource and it costs money and it's difficult to get. But it's also to optimize the yield of the plant as well. So maybe it's use more water if that means getting more yield. But the key thing is understanding what's going on and knowing what you're doing, and being able to measure that over multiple seasons, and build up a data picture that can give you an informed picture that you can work from within for your actual farming itself. And obviously meeting sustainability targets is part of that. We worked with a citrus farm in Brazil. And their ambition was to reduce water input by 3%. Doesn't seem a lot, but when you've got 10,000 hectares, can mean an awful lot. So, and this is just a quick close-up of what that looks like. At the bottom is the soil moisture sensor. And then we've got our sort of terminal, and then a modem right at the top, just to give you an example of what that looks like. And that's on a farm that looks something like that. So that's it from me. So that's satellite IoT, the quick overview. And yeah, thanks very much for allowing me to speak.
Fantastic. That was quick, but it was a fantastic presentation. Thank you, Eric. I really appreciate. Let's take a quick 10 minutes to discuss, you know, some latest developments, if you have known in the industry. I'm just want to give a quick summary from today's presentations. Like Kathy was mentioning about a Ningbo Ocean pod with lots of HD cameras, with remote crane operations, automated logistics with unmanned tracks. Emily was mentioning about delivering digital media, IP-centric solutions, integrated with the IP 5G ecosystem, 5G broadcast, media streaming as well. Ajna was mentioning differentiated service offerings with MVNO, customized premium offerings, enhanced customer experience. Heikki was mentioning live broadcasting with many cameras, wireless film crews, 5G enterprise, small cells as well, 5G phone with private network SIM card. That was interesting. Also, Zenab was mentioning time-sensitive networking with Ethernet, EUB, Ethernet, ASNs as well, with the TSN bridge. Williams mentioned media streaming, mobile video, 80% data traffic. The MEC is so important in this case, 5G APIs, broadcast multicast. Also, in terms of Adil, you mentioned private cloud, public cloud, and also Zenab, integrating advanced sensors, data analytics, and automation with IIoT. And lastly, Eric, you were mentioning LEO orbiting satellites, bringing IoT connectivity, sensors, terrestrial gateways. I think this is quite critical because from 2024 to 2027 onwards, there's a convergence is taking place between the cellular and together with the satellite as well. A lot of convergence is happening together. I have only one clarification. I have only one question. Anyone feel free to answer this, or maybe you have any other points as well. Release 3GPP release 15 has already been really commercialized. We see a lot of trials. That's a lot of commercials are taking place. However, the release 16 is still on trial basis. Maybe I'm wrong, but what I can see, what I understand, what I study around the world, the release 16 still on trial. There's not much of commercial developments going on. We know for the fact that release 16 is so important in terms of enhancing mainly on the UHD videos, right? Mainly on the downloads, smoother streaming, faster downloads, cloud gaming, AR, VR stuffs, URLLC, and MMTC, smart metering grid, and all that kind of stuffs. And when we look from the standardization process, they have a timeline to finalize the release 19 by the end of this year. And and everyone started talking about 6G. Hey, come on. What is the status of 5G commercialization? How are the countries globally are looking at? Maybe, the Europe is a bit behind compared to the US and Asia in the fact. So anyone wants to take it up? What is your point of view? What do you see? Would you mind to share?
Yeah, maybe one comment to the kind of the specifications and implementation. So if you look at the 3GPP history, there's a lot of specifications that never made it to commercial use. And I mean, you don't have to go to release 16, but I think at the beginning of the 5G era, there were high hopes regarding NRU, which Qualcomm was highly promoting kind of those days. But then I think what we all need to recognize is that the chip vendors and the UE vendors and the infrastructure vendors, they are all coin-operated. So somebody has to keep throwing in coins if you want to have the functionality, and this is not happening for the more advanced features in 5G, unfortunately.
Maybe if you allow me to give a comment here, what's going on is most of the telco operators still they are earning money from the 5G NSA, and the 5G SA itself as an implementation is still taking time, especially for those operators who have gone from the first day with multiple vendors. Some of them they go from multiple vendors from their strategy point of view because they need to have multiple vendors. And the issue now is that still the NSA it's working fine without any you don't need any transformation. The transformation is done. With the SA, you have a bunch of workloads that you need to move to be based on 5G. You have license transformation. You have work to be done. About the release 16, some of the vendors they have already released 16. It's available. It's available within their. It's available even in the software release. It's already there. The 17, 18, 19. I don't expect that, especially. There was 4 years ago, there was like discussion about network slicing. That when you want to, because one of the biggest driver of the 5G itself is the network slicing. And network slicing, when we wanted to make it on the field, it's difficult simply. You have RAN, you have IP network, you need the core network. So you have multiple domains where you need to enable orchestration, automation, and so on. And you need to purchase DO for the RAN, DO for the core, DO for the orchestrator for the IP. You need to take in also the responsibility of that each vendor is coming with his own NVO, its own VNFM. You have integration issues. It's a big deal. So what's going on now? It's most of the corporations they say just okay, we will be like we calm down. We are going with the 5G SA. We will not hire you up. 2 years ago, we have invested in 5G SA. We have the software here, but we didn't go live. Yes, we didn't go live. We will be steady a little bit. We will calm down until things they are mature. As a surprise, finally, to just say, as a surprise, people they are talking about 6G. They are talking about 6G. We didn't consume the 5G capabilities at all like 30%, 80%, and 20%, sorry. And still now they are talking about 6G and AI, and it's a little bit, I feel that from where I'm working, I'm doing, I see that just hoax or just talking, but in reality there's no such things.
Just one word. I agree completely with what Adil says. And I believe that all this buzz on 6G, on slicing, etc., it's created kind of expectations that make me feel that I'm starting hearing people saying, well, 5G is not delivering to what we were expecting. The other day I was listening to this podcast, the 5G guys, and they had this attendee who was criticizing the fact that 5G is not delivered on what was expected, but it's exactly what Adil says. I mean, to deliver to what was buzzed on and expected, you need to implement a lot of things that are very, very complex. And it's not easy. And the telecom operators, as Adil said, need to monetize their 5G NSA already. So
Anyone else wants to add? The most scary thing I noticed was that I was just trying to monitor the standalone deployments. Towards the end of last year, it was about 49 operators have deployed standalone. And today's date is still 49. So there is no progress for the last 5 months. I think a lot of them are still testing it out and haven't commercially launched yet on the standalones. So it's quite kind of tricky, right? I'm not sure whether most of them who are in the NSA want to wait until the 60 is ready and quickly jump directly to 60, or are they going to wait another next couple of years? Because I know standalone is quite costly in that sense. Yeah.
What I think the kind of waiting for the next G is not the solution, but I think one of the challenges in moving from NSA to SA is that that has plenty of impacts on the business support systems. And if you have your existing customers basically served very well by the 4G core and the existing BSS, then why would we invest in a new system that basically gives the same and then you have still the problem that some of the UEs will not work with the standalone deployment that you have as that ecosystem is not mature either. So, but I think I mean my take is that if we want this industry to grow, then I personally believe it needs to grow kind of outside of the big telcos, and like Adil commented, it's sort of for somebody who is running 2G, 3G, 4G, and 5G, it's utterly complex to try to introduce something new in the network and in their own organization. So I sort of prefer giving people the possibility to take their fate into their own hands and buy a box from somewhere, or I can rent you a network for a month and you pay a few €1,000 for it, and you're good to go to your festival or into your forest or whatever the use case is. And I basically hope and I encourage everyone to join this path, because by adding complexity into the existing telco networks, we will not get anywhere.
Anyone wants to add anything?
If you allow me just in one sentence, the only thing so where I see that 5G is worthy is the private 5G for time being. Before, the expectation it was about the network slicing, as I said, because it's a event based. The slice it's an event based. You can you have an event in one city, big city, whatever the event, you can create a slice, small slice, virtual slice. And the 5G it came also with the think about cloud, because the 3GPP, because I have read the specification for 15 and 16, they have the expectation that 5G, when it will come, there will be a booming in devices. And that's why we need cloud. And that's why we need microservices. And we need NEF, NRF, sorry. And we need NEF for exposure to the third-party applications. And will be so much development and so on. But in reality now. But where I see now is private 5G. Private 5G, I think this is the only use case where there will be business. The normal 5G, like B2C, it's like 4G, where people they will purchase SIM card and package and so on. And so on.
Okay. Yeah, one story I want to tell you at this point. I disappeared at some point in time from the meeting as I had a power outage, which is very seldom in Finland. But they are here changing the power meters because they are all connected via GSM, and now I think they put in something more modern that will survive for some tens of years. But that's, I think, at least in Europe, the sunsetting of the old technologies is quite difficult, as you have lots of the utilities basically relying on the early IoT solutions, and this is also holding back the industry from reducing the complexity and really sunsetting the old technologies.
Emily, you want to add anything?
Well, it's just let's say funny because I'm less familiar with the 3GPP world, of course, than I am with the traditional broadcast systems. But hearing you, I just realized we are facing the same issues. I mean, technology can do great things, but then there's still a need to find how those technical advances can fit into some new opportunities that could be valuable for the market. And sometimes there are some, of course, and but there is still difficulties to, or it's not enough to make them adopted by the market. So that's somehow interesting to hear.
Kathy, I think you are safe because private 5G is quite in the safe mode.
Yeah, I posted in my LinkedIn. I just have one last comment. Go enterprise, go private wireless, and go seaport. That's it.
I'm just going to say that 2G just got turned off in Switzerland, and a lot of IoT devices in Switzerland were on that service. So that's going to keep happening across Europe, I think, that sort of, or across the world, that sort of change where there are disruptions that happen. So obviously, you know, from my perspective, that's great because satellite, we feel can fill that gap. But you know, it's a combination.
Yeah.
I guess.
So
I mean,
indoor and in urban areas, I think.
Yeah, not in. Yeah, of course not. Of course not.
Yeah.
But I was looking at the land mass of urban areas compared to the land mass of everything else. It's kind of interesting, you know. I mean, 98% of the people live in the cities, and there's good connectivity, there's good 5G connectivity and whatnot. But when you get out, it's different.
And I really hope the GSOA and the 3GPP will work together, you know, particularly in terms of the spectrum sharing stuff, right? Because, you know, there was always been argument in terms, I'm protecting my spectrum for my satellite service providers, and those guys are protecting the mobile operators. And we have to come to a consensus that, you know, so that it can complement each other. So that is another interesting thing we can see in the convergent space.
NB-IoT, which is basically a 5G technology because it's a little slither on the side of 5G, you know. So I mean, it's got a tremendous potential to be, you know, the big winner. At the moment, it's about 50-50 call between LoRaWAN and.
Eric, the problem with narrowband IoT is that you still need to implement the basically 3GPP authentication and much of basically the mobile standards, and that's of course good because Katie gets her salary paid by the IPRs, but for the rest, I think LoRaWAN is sort of cheaper.
Yeah, absolutely. I couldn't agree more.
All right. So thank you so much. I really appreciate for your contribution today. This video will be uploaded on YouTube in the next couple of hours. To the audience out there, please do subscribe our YouTube channel by clicking the subscribe button on our YouTube. And I'm so grateful to all of you. Thank you so much. I really appreciate for your time. Till in the next session. Thank you so much. Take care.
Thanks.
Have a nice
Thanks, Ganesh. Thank
Thank
you.
you very much. Bye.
Thank you,
Bye-bye,
Ganesh.
everyone.
Bye.